All right, folks, welcome back and kind of a little review of where we're at and what we're doing. So, hopefully, most of you guys are starting to get comfortable with some of the basic ideas of assembly. If you're not quite there yet, do not sweat it. It is a very hard class, as I said. But anyway, I'm going to keep going. So, we're at the point now where we are talking about, some of the fundamental concepts of programming that may seem trivial in a higher level language, but in assembly, once you get it, it's still pretty trivial, but it's not so obvious at first. So we're talking about if statements and loops. This video I'm going to show you if statements, and the next video I'm going to show you loops. So we're going to use a really trivial if statement for this example. So it says, suppose R1 has some number in it. In this case, I have 11. And I want to compare it to the value of 10. If it's less than 10, into R0, I want to put 1 in it. Otherwise, I want to move 0 into R0. And I'm going to do it in two ways. I'm going to use conditional codes only and conditional codes and branches. So I'm going to show you the branch way first because the branch way is a little bit more code, but it's still pretty easy to understand. So the first step to any if statement I've already done. You have to do your comparison. And what compare is actually doing under the hood, if you remember those flags, such as zero flag, the carry flag, the overflow flag, the negative flag, compare is updating those flags. It's not actually returning anything to the user. So depending on what those flags are, depending on what conditional code you use with a statement, a certain part of the code will run, just like an if statement. So once I do my compare, the next step is to set up my cases, and we do that using branch. We're going to branch if we are less than to our case 1. We are going to branch if greater than or equal to case 2. So now that we have our cases set up, you can use any name that you want. We actually want to handle our cases. So case 1, we would like to move the value of 1 into R0, remembering that you have to explicitly exit each case. And I will explain why you do that in just a second. And then after you're done handling your cases, you have to make sure that you place the exit past everything. So what branch actually is doing? Let's say that case 1 is going to run. So if this less than condition is true, branch tells the computer, okay, go to the first place that I see this name right here. So I'm going to look for case 1. It's not on line 31, it's on line 32. So I'm going to jump straight from 30 to 32 and then continue my code from that point on. That's what branch is doing. So I'm going to do my move, and then I'm going to branch to my exit, which is all the way down here. Now the reason why you have to have exit, you can probably see it now. If I weren't to have exit on my case 1, indeed the move command is going to work just fine. But you're going to trickle down into case 2, even though you might not necessarily want to, because the computer doesn't know any better. It's just going line by line, just like it thinks it's supposed to do. But we're telling it explicitly, if this case runs, I don't care what happens after. I want to go straight to my exit. So I guess, yes, theoretically for case 2, you don't have to do it, but it's just good practice to be consistent. So enough of my jargon, let's build the code and see if it runs. All right, so we have the value of 11 in R1. So I'm comparing it against 10. Are we going to branch into case 1 or case 2? Okay, that one didn't branch anywhere. Oh, now we go into case 2. So we do move R0, and then we exit. I'll go ahead and show you the other case. So now we have 9 instead of 11. So we are now going to go into case 1, do our move, and then we are going to jump straight to our exit past case 2. All right, so that's way number 1. So way number 2, I think you're going to like a lot better. I apologize if my video seems just a little bit choppy because I'm pausing and unpausing all the time because the keel environment on my machine for some reason is being very buggy. And whenever I actually run the debugger, 3 times out of 5, it likes to just shut itself down, which I do not know why it's doing that, but I'm trying to work around it. So, anyway, back to the code. The second way we're going to do this is using conditional commands only with no branching. I think you're going to like this way a lot better for two reasons. Reason number one, there's a lot less code that you have to write. Reason number two, once you actually know how to read these, you can almost read them to yourself in English and it will make complete sense. So the first part, exactly the same. You have some initial value in R1, and then you have to do your compare. And then you do something like move if less than into R0 the value of 1, and then move greater than or equal to R0, 0. It took me about 10 seconds to write. And now the cool thing about conditional commands such as LT and GE is they can be used at the end of any command. Move, add, shift, rotate, even compare. So this is a really powerful idea. You can't use it all the time, but you can use it in cases like this. When you have to do just one thing in each condition, this is generally the way to go, which that one thing is just moving a value. Now, if there are multiple things that you have to do in one case, it might be better to use branching for that reason. But for cases like this, use conditional codes always. So let's build it and see if... All right, so with 9, move LT is definitely going to run. So if you watch R0, that goes to 1. And then move GE doesn't run. And you guys probably see the idea. I don't have to do the other one. If we were to have 11 in R1, then move LT would do absolutely nothing, and then move GE would indeed move 0 into R0. So I hope that was helpful. I hope that supplemented what was said in lecture, because I think the lecture does a pretty good job at explaining exactly what you need to do these kind of things. Again, these videos are not meant to replace lectures. I'm going to keep stressing that. I mean, they're meant to help you understand if something was unclear, but that's about it. So that's if statements. So stick around and we will talk about loops in the next video.